An example of that is where order matters. We did this ABC does not equal ACB in a permutation. They are not the same. Whereas in a combination, ABC equals ACB. The order. Hopefully that might clarify that a little bit. There's formulas for both of these. There'll be more answers for which one? Is there more permutations or more combinations, do you think? More permutations, yeah. I was going to go through that example. So the formula for permutations is this one. And the formula for combinations we had before, and that's our NCOR formula. It doesn't matter what order we look at things in, just how many there are. So this is the NCOR one. N choose, or we used to say, n factorial all over or factorial n minus or factorial. So there's a bigger divisor here. Okay, so they're the two formulas that...
Are these both given to us?
They're both given to you, yes. Yeah. Okay. So going forward, we can use either one of those formulas. Let's look at an example of both type questions now. Let's first, I have it here, so you don't need to take it down. Okay. A chess whoops, that's gone too far. A chess tournament runs with 16 teams. How many different ways can the top 8 positions of the competition be filled? Is that a permutation or a combination?
Permutation.
It's a permutation, yes, because the order does matter. So what's the answer to this? 16 teams in the chess, how many different ways can the position be filled? So we were doing it yesterday with a logic method for permutations. You can just go, well, first place, there can be 16. Second place, there can be 15, 14, 13. How many places were there? 8.
5, 1, 8, 9, 1, 8, 4, 0.
A lot, yeah, it's a lot, yeah. So 1, 2, 3, 4, 11, 10. One more, geez. So there are 8 positions. How do we get 1, 2, 3, 4, all these multiplied together? Because there's 16 people can fill first position. Then there's only 15 people to choose from for second position. Then there's only 14 to choose from, and so on, right down the positions. If you want to use the formula, you would go, all right, 16 factorial divided by, because there's 16 positions, but divided by 8 factorial, yeah. So we're taking, like, this is a factorial, but we don't include this. Why don't we? Well, they're the 8 positions that don't matter, I suppose. So we divide it by 8 factorial. 16 minus 8 factorial gives us 8 factorial. So we could use the...
I don't like the whole there are no restrictions. That's so confusing.
Well, this is a combination now. So we're going to look at this second question. So we can do this logic. We did most of these with logic yesterday, not the formula. Let's look at the second question. How many different teams of 3 can be selected from a squad of 8? So this is a combination. That means James, Paul, and John is the same as Paul, James, and John. The same team. Doesn't really matter. Right, so how would I work this out? Squad of 8, 3 different teams. Let's use the formula. So a squad of 8, 8 in a squad. Let's use the formula for this one. That's without a D, okay. Let's use the formula. So it's 8 choose 3. We did this in binomial theorem, 8 choose 3. Now this is kind of what it means. 8 factorial all over 3 factorial, 8 minus 3 factorial. Let's work this out without the calculator. 8 factorial all over 3 factorial, 5 factorial. Do you remember how to simplify our factorials?
That's 5
Yeah.
3 squared times.
Write them out and then cross out what we can cross out. So if it was a non-calculator question, this would definitely be what we have to do. This is another bad pen.
Chuck in the bin.
Yeah, that's my bin pile. Remind me to do it afterwards. So this is what a factorial is, in case you forgot. All the way down to 1. So we see a bunch of these can cancel out here. 3 times 2 is 6. And 8 times 7 is 56. There's 56 different teams that can be selected. What about this second question? The team must include the captain.
How do we know
So this is somebody that must be in. He must be selected. Paul is on every team.
Just minus 3 members. We do Alex.
So still teams of 3. Right, how do we do this? Still.
5, choose 3. Oh, 1 times 7 times. Wait.
Okay, yeah.
It was something like 1 times 8.
Well, we can think about it. One person must be selected. So what's left for the rest of selections? 7, you're really choosing from 7 people, teams of 2. If that makes sense. So we're going to go 7 choose 2 times the captain. So the captain is included already. So the captain's just one person. So you can multiply by 1 if you want. But it's just the other 2 positions, 7 people will be chosen to do it. So use the same factorial thing. We do 7 factorial. So we're doing 7, choose 2 people. In any order, doesn't matter.
Wait, sir.
Yes.
Isn't it meant to be 1 captain each team?
The team must include their captain. Okay, this is vague. Usually IB questions would remove any vagueness chance. So they usually deal with codes and stuff like that. But this means that the captain is in the 8 people and he must be selected on the 3-a-side team.
I don't get the formula, like the logic behind it.
So it's just he's just not in it. Like he chooses which person goes to which team.
He chooses.
So he's not.
He's on the team no matter what. So he's already filled the first spot in the team. So there's only 2 spots left on the team.
You need that.
Oh, okay. Yeah.
Okay. So 2 factorial, 5 minus 2 factorial. 5, 7 minus 2 factorial. Because there's only 7 people. The squad of 8 is now really just a squad of 7 with 2 people to choose from. Because one person's automatically chosen.
I thought there were like 3 teams that get to.
No. This is where things get confusing with these. When things are, as we saw yesterday, got confusing fast.
42 divided by 2.
Okay, so the 5's gone, 2 gone into there, 21. Okay, and that's a basic introduction to permutations, combinations. Let's specifically look